Alright, so in this video, I'm going to talk about the Chatelier principle, worksheet 1, but I will separate into two videos. So the first video, I'm going to talk about the concentration and so I'm going to talk about the concentration, the catalyst inhibitor, and also I'm going to mention about solid and liquid and gas system. Okay, and then the other video, I will talk about the temperature. Okay, so first of all, what is meant by I want to introduce the concept of equilibrium. So at the equilibrium, which is this symbol, okay, the reverse way will equals to forward way. So what does that mean by reverse way is when you go back to the left direction, meaning like when you form the reactant, and the forward way meaning when you go to the right direction where you form the product. So that means when at equilibrium, both of the rate are equal. They have the same speed to form reactant and product. I say same speed, not same number of the reactant and product. I say same speed. Okay. So what does that mean by the Chatelier principle is any factors going to mess up this equilibrium. That means they mess up the rate, and the equilibrium will shift to a new position such that you will minimize the changes that I give to you. So for example, let's say I'm 100 pounds. Okay, so if you change my pressure, you change my temperature, you change my volume, my equilibrium 100 pounds change. I may change it to 200 pounds, I may change to 50 pounds. So then my immune system will automatically shift my equilibrium to the new position such that your influence on me will be minimized. Then I can keep myself as 100 pounds again. Now, the four factors will affect my equilibrium, will affect my weight, which is the concentration and temperature. So we will talk about that in the worksheet 1. And the pressure and volume, they are only for gas system only. That will be the other worksheet. Now, these four things, any changes on these four things will affect the equilibrium. Now, there are two other things that no matter you change on it, will not affect the equilibrium. That means I will stay the same position. Number one is no matter you add or you remove catalysts or inhibitors, because if you add the catalyst, you will actually speed up both the reverse rate and the forward rate. Speed up both of them. So my equilibrium still stay the same. I did not form more reactant, I did not form more product. And then inhibitors is I will decrease the rate of the reverse, I will also decrease the forward rate at the same time. So both of the rate will be decreased, but my equilibrium stay the same. I did not form more product, I did not form more reactant. Another factor that will not affect the equilibrium is when I have the gas system, if I add or remove any solid or liquid, there will be no change because I'm in gas system. What does it mean by gas system is in the equation, I will see some gases. So if I add solid, if I add liquid, there will be no shift in the equilibrium because I'm in gas system. All right, so let me just talk about the first part is the solid or liquid, which is on the bottom of the principal table. The green, my paper is white, but your paper should be green. Now, if I have the gas system, that means in my equation I have gas. Any additional removal of the solid and liquid will be no shift at equilibrium. Okay, no shift in equilibrium. What happened is because the concentration of pure liquid or solid, they are 100% pure, so that means there will be no shift in that. So the reason you're going to write on that, if that's the case, you will just write, oh, the H2O is a liquid in gas system. Oh, the Na is a solid in gas system. Then just write this is the reason, and you just write no shift, no favor. All right. Now, let's talk about the catalyst inhibitor. So again, if you have catalyst or the inhibitor present, will be no shift equilibrium. I just explained to you, right? They will increase the rate both at the same time. They will decrease the rate at the same time. So then will be no shift and no shift in the equilibrium and no favor in either product or reactant. So then the reason you just write is catalyst present or inhibitor is present, and that's it. Okay, this is very simple. Now I'm going to talk about the concentration. Now concentration, you will see the bracket. So if you increase the concentration, you want to stay away from that substance because you want to throw away the extra substance. So what does that mean is, let's say, I'm already happy. Okay, so let's say, just give an example. So this is Mrs. Chen, right? Mrs. Chen is already at equilibrium, right, with this body weight. So if I want to increase any fat, I want to increase the concentration. So I want to give Mrs. Chen more fat. So what Mrs. Chen wants to do is probably stay away from that fat, because Mrs. Chen is already equilibrium now. If you mess up his system, you're going to give her the fat. Suddenly, she does not want to stay with it. She wants to stay away from it. Because, why do you want to stay away from a substance? Because you throw away the extra thing. So in this case, if you have the concentration increase, you want to stay away from that concentration. Okay. Now, on the other hand, if my system is already in equilibrium right now, all right, so this is already equilibrium with this fat, okay, she is already at equilibrium. Now, you suddenly want to decrease the concentration, right? So that means I'm going to take away this fat. So what happened is actually the equilibrium which want to shift toward to the system. Oh, please give me back. So he want to stay away from that. Oh, I'm going to go toward to the substance. Because the reason is he want to get back the lost stuff. Okay, because you're already at equilibrium, but you suddenly take away my stuff, you decrease my concentration. So of course I will shift equilibrium toward to the substance because I want to get it back. So then when you decrease the concentration, you want to stay toward to the substance because you want to get it back. All right. Now this the reason, all the reason that you can use for the reason part. They are all the reason part. You can use it on the worksheet. Right. All the reason part you can use it on this worksheet. Okay. So let me just start with this page. Okay. So first of all, you recognize that this is equilibrium. Equilibrium meaning I must have arrow, both arrow, like both equate, like both direction. If you only have one direction, that is not LE principle question. You can't use equilibrium, okay? This must be in equilibrium, both sides, all right? Now, let's say N2 is increased. So I'm using the reason part here, okay? So I increase the concentration of N2. So on the reason, I'm gonna write N2 go up. Okay, so what happened? Oh, if I increase the concentration, you want to stay away from it, right? If I increase the concentration, you want to stay away because you want to throw away the extra thing. So in this case, I want to stay away from N2. I want to stay away from N2. Now again, all the reason thing, they are on this column, right? They're on this column. Right. So I want to stay away from N2. So if you look it up, this is my equilibrium. If I want to stay away from N2, that means I don't want to stick on N2. That means I don't want to stick on the left-hand side. I want to stay away from N2. That means I want to shift to the right-hand side. Because I want to stay away from N2. I don't want to stick on this, so I want to stay away. So I'll shift my equilibrium to right-hand side. So because I shift my equilibrium to right-hand side, so shift equilibrium, okay, shift my equilibrium to the right-hand side. So because I want to shift my equilibrium to the right-hand side, I will favor more product because the right-hand side is product. So what does that mean by favor more product? That means I will form more NH3, okay? Now I'm going to do, let's see, the other question I want to do is, this one, NH3 is increased. So NH3 increase. Right, so I increase NH3. Again, same thing. When I increase something, I want to stay away from it because I want to throw away this extra substance. So when I increase the concentration, I want to stay away from it. Right, so this is the reason. I increase something, I want to stay away something. So I'm going to stay away from NH3. I want to stay away from NH3. Okay, so if you look at this equation, all right, NH3 is on the right-hand side of the equilibrium. So I want to stay away. That means I don't want to stick on the right-hand side. I want to shift to the left-hand side. Okay, because I want to stay away. That means I don't want to stick on the right. I want to stick to the left. Because I want to shift to the left-hand side of equilibrium, so I shift to the left-hand side, that means I will favor to form more reactant because my reactant are on the left-hand side. Okay, so let me do number 5, okay? Now N2 decrease. So N2 decrease. Okay, so N2 decrease. So what happened when something concentration decrease? that means I want to stay truer to the substance because I'm already happy. Now you take away my fat, I want to get back the lost substance. So if I decrease my concentration, I want to stay truer to because I want to get it back. I want to get it back. Okay, I want to stay true at that. So if I decrease my N2, I want to stay truer to N2. Right? So if I want to stay true to N2, so look it up. Okay, now this is equilibrium. If I want to stay true at N2, that means I want to stick onto N2. If I want to stick onto the N2, I want to shift my equilibrium to the left-hand side. Right? If I want to stick to the left-hand side, that means I want to favor to form more reactant. Okay. Now let's say NH3. Okay. So my NH3 is decreased. Okay, my NH3 decrease. Again, so if my NH3 decrease, right? I decrease something, right? You want to stay true at that because you want to get back the lost substance. So if my concentration go down, you want to stay true at it. You want to get it back. So in this case, will be toward to NH3. You want to stay true at because you want to get it back. All right. So you want to look it up here. Oh, I want to stay toward NH3. That means I want to shift my equilibrium to the right because I want to stick on here. I want to stick toward NH3. That means I will shift myself to the right. Now, because I want to shift my equilibrium to the right, that means I want to favor my product. Okay. Right. Now, I think you can do the rest. Now, the number 9 is catalyst is added. So what does it mean by catalyst added? So again, if I add my catalyst, will be no shift because the catalyst is present. All right, so no shift, no favor. So catalyst will be no shift, no favor. And then you can just write the reason. So this is the reason. So catalyst is present. So both the catalyst and the inhibitor is the same thing. Got it? Now let me go to the back. I'm going to do a few more. Okay, so, right, let's say I'm reading, this is equilibrium. All right, so N2O4 is increased. So N2O4 increase. N2O4 increase. So if I increase, I want to stay away from it. Right? If it increase, I want to stay away from it because I want to throw that away. So I want to away from N2O4. I want to stay away from N2O4. So that's the equilibrium. I want to stay away. That means I don't want to stick on the left. I want to stick on the right. If I stick on to the right, will be from favorite product. Okay. Now, if I decrease N2O4, right, so number 4. Number 4, if I want to decrease my N2O4, right, because I want to decrease my N2O4, so, oh, you lose something, then you want to stay true at it because you want to get it back, right? So you want to stay toward N2O4. Right? If we want to stay toward N2O4, so you want to stick on here. That means you want to shift your equilibrium to left. That means you will favor reactant. Okay. Now, the bottom, there's a question here is, you see that this is a gas system because, I'm going to write, this is a gas system. Because I do have gas. I do have gas. But on the other hand, I also have solid. Okay, so we just said that if you have solid and liquid in the gas system, any changes in the solid or liquid will be no shift because they cannot change in the concentration because they're 100% pure. So you will just write whatever is the solid or whatever liquid is the gas system. So let's say CaCO3 is added. So you don't want to say because you add CaCO3, you increase concentration. You can't say that because this is a gas system and this is a solid. So you cannot say, oh, CaCO3 go up, you want to stay away from CaCO3. No, you can't because this is a solid in a gas system. So you want to write no shift and no favor. All right, and then the reason you're going to follow that is whatever that thing is a solid in gas system. So I'm going to write CaCO3 is a solid in gas system. All right, so you have to be really careful which one is solid, which one is solid. So let's say number 2 is also a solid, but number 3 is CO2. Now you look it up, CO2 is a gas. Then you want to think about its concentration now. Okay, so CO2 is added, that means CO2 concentrations go up. Then what will happen? Okay, so see that you sometimes you don't have to see the concentration. You just say, oh, CO2 is added. So you want to look up, oh, if this is a gas system, okay, I can increase the concentration of CO2, no problem. Okay, but if it's like not like a like say like CaO is a solid in a gas system, then will be no shift. So you have to really carefully. CO2 is a gas. Then when they increase, there will be concentration factor. Okay.